So picture this. You're sitting in a conference room, right? And the coffee went stale about, I don't know, 2 hours ago.
Oh, yeah, we've all been there.
Yeah, exactly. You're listening to yet another speaker. Could be a tech founder, maybe a policy director, or, maybe it's just your own manager. And they're up there in front of some slide deck, pounding the table saying, we need to move fast.
Right. We need more velocity.
Yeah. Accelerate. And it really doesn't matter if you work in software or government or heavy manufacturing. Like, you have lived through some version of this exact speech. Everyone uses slightly different jargon, but they are all circling the exact same invisible problem.
It's basically the universal battle cry of the modern organization,
Yeah.
Reduce cycle time, increase velocity. And if you actually look at the data, it is almost always completely ineffective at solving the underlying bottleneck.
Right, because it's just rhetorical filler. It sounds great on a slide, but it persuades absolutely no one in the room. So today's deep dive, we're going to fundamentally rewire how you look at that problem.
Oh, really are?
Yeah. We're building this discussion on a fascinating stack of research. This is the latest edition in the Connected Ideas Project, or TCIP for short.
It's a great collection.
It really is. We are looking at this cross-section of white papers on industrial strategy, some policy memos on global biosecurity, and deep systems engineering documents.
Yeah, quite a mix.
Very broad. But our mission today is to distill all of this into one groundbreaking concept that the text calls the Tempo Thesis. We want to change how you think about time.
Right, not time as a deadline.
Exactly, not a calendar invite, but time as the ultimate hidden variable that decides whether your projects or your business or even entire governments actually function in the real world or just, fail on paper.
So we have to start by completely stripping away the word fast. That's step one. The fundamental premise of the Tempo Thesis is that telling a team, we need to move fast, is just looking through the wrong end of the telescope entirely.
Because it confuses speed with time, right?
Exactly. Conflating the concept of speed with the concept of time has basically made the real structural issues totally invisible to most leadership teams.
Okay, let's unpack the mechanics of that. Because, in the business world, we treat speed and time as just interchangeable synonyms, If something takes less time, it's faster.
Right, it's just how we talk.
Yeah, but the research draws a very sharp, deliberate line between the two.
It does. It says speed is really merely a metric. It's something you benchmark and you optimize within a system that already works.
Ah, okay. That's a huge distinction.
Yeah, so if you have a fully functional automotive assembly line, sure, you can try to speed up the conveyor belt. That's speed. Time, on the other hand, is the medium in which all your various systems and departments actually have to compose and coordinate with each other.
Oh, I see. I think of it, it's like having a world-class sprinter in a relay race.
Perfect analogy, yeah.
Right. So let's say your first runner runs their leg in absolute record-breaking time. Their speed is phenomenal.
Off the chart.
But the person they are passing the baton to is casually walking down the track eating a sandwich.
Right. They're just strolling.
Yeah. So the first runner's speed is totally irrelevant. The baton is going to hit the floor because the coordination between the two athletes is completely broken.
Exactly. And engineers actually have a term for that. They call it temporal coupling.
Temporal coupling.
Yeah. It's what happens when two systems that absolutely must coordinate to achieve a goal are just forced to operate on fundamentally different timescales. When that happens, the entire system fractures.
Wow. And it's not because anyone did a bad job.
That is the crucial thing to grasp here. The fracture doesn't happen because any individual component failed. Your sprinter didn't fail. They ran a great race.
And the walker is doing exactly what a walker does.
Right. The system breaks because time itself became the fault line.
That makes so much sense when you apply it to the workplace. If you listening have ever tried to get a new software tool approved by your company's IT compliance board, you've been a victim of this.
Oh, absolutely. The classic IT bottleneck.
Right. Your development team is operating on a 2-week sprint cycle. They are moving.
Right.
But the compliance board is operating on an annual audit cycle.
They're essentially the walker in this scenario.
Exactly. Both teams are actually doing their jobs really well, but temporally they are entirely incompatible. The components just don't compose.
And that IT compliance example perfectly mirrors where we see this temporal fault line on a much, much larger macro scale, which is governance.
Oh, right. Policy and tech.
Yeah. Specifically, how society attempts to govern the rapid advancement of new disruptive technologies.
Which is always a mess. The gap between when a new technology drops and when a regulatory body actually responds to it. The TCIP framework labels this governance latency, right?
Yes, governance latency, and the text breaks it down into three distinct phases.
Okay, what are they?
First, you have detection latency. That's just how long it takes to realize a system is behaving in a new way.
Like realizing AI can suddenly write code.
Exactly. Then second is interpretation latency, which is the time required to understand what that new behavior actually means for society.
Which can take forever.
Right. And finally, execution latency, the actual time it takes to implement a policy response.
And the prevailing cultural narrative, what everyone says, is that this latency is a bug, that government is just inexplicably bogged down by lazy bureaucracy.
Everyone assumes it's just broken. But the Tempo Thesis introduces a much more profound perspective here. It proposes that governance latency is not a flaw at all. It is a deliberate temporal architecture.
Wait, deliberate, like an architecture designed for a world that simply moved at a completely different pace.
Precisely. Think about the actual mechanics of lawmaking.
Yeah.
You've got congressional hearing calendars, notice and comment rulemaking periods, interagency review cycles.
Lots of red tape.
But those mechanisms natively operate on a decadal timescale. They are literally designed to take years or decades to fully process change to ensure stability.
But the technologies they are trying to govern today, like these artificial intelligence models, they're evolving on a monthly timescale, sometimes weekly.
Yeah, it's incredibly fast. And the gap between those timescales isn't just an administrative delay. That gap is a massive, unchecked space where the actual outcomes in the real world are totally determined before the formal governance process even officially begins.
Okay, let me push back on this a bit, just to play devil's advocate for you listening.
Go ahead.
When we talk about slow government, isn't that often considered a safety feature? I mean, if government moved at the hyper speed of the tech industry, wouldn't we just end up with really rash, reactive, maybe dangerous laws? We probably don't want the legal system adopting a move fast and break things mentality.
Well, that is the exact trap of conflating speed with time again.
Oh, interesting. How so?
Because the goal of temporal design is absolutely not to make the government act recklessly faster. Incredibly dangerous.
Right, nobody wants the walker to suddenly try and sprint and pull a hamstring.
Exactly. The goal is to build governance architectures whose operating timescales natively match the domain they are trying to govern.
Okay, so it's not about hitting fast forward on a congressional hearing. How does that actually work mechanically?
You build what the framework calls modular governance, or pre-authorization frameworks.
Pre-authorization, what does that look like in practice?
So rather than waiting for a crisis to occur and then spending 3 years interpreting it and 5 years writing a specific law, you design a framework that is pre-authorized to act the moment certain thresholds are crossed.
So you establish the boundary lines today.
Yes. For example, legislation might dictate that if any new AI model crosses a very specific threshold of computational power, it automatically triggers an independent safety audit.
Oh, wow. So you don't need to pass a new law for each individual model. The governance is essentially preloaded.
Exactly. It aligns the decision cycle with the environment's rate of change.
That really reminds me of how the FAA struggled to regulate commercial drones a few years ago.
That's a great example.
Right. The regulatory process for aircraft took years. That's just how the FAA works. But consumer drone companies like DJI, they were releasing these new, vastly more capable models every 6 months.
They were iterating so quickly.
Yeah, so the government's rules were completely obsolete before they were even printed.
Because capability without temporal coordination is just inert potential energy. It sits there looking very impressive on paper, while the clock simply runs out on your ability to actually shape the outcome.
And while that clock runs out, real-world advantages are being won and lost permanently. I mean, governance latency shows how slow rules fail fast tech, but this temporal mismatch goes way beyond stalled laws.
Oh, it really does.
It literally decides who wins and loses entire global industries.
Yeah, if you look at the industrial strategy sections of the TCIP research, there is this fascinating application of this to biomanufacturing. It introduces what they call the circles and spirals thesis.
Circles and spirals.
Yeah, and this is a purely temporal argument about why certain strategic industries just get stuck in neutral.
So the circle is essentially a trap, right? Like an industrial time loop of doom.
Basically, yeah.
So the mechanics go like this. A company has no massive production experience, which means they have no data on their manufacturing yield.
Right, you don't know how efficient they can be.
And because they lack yield data, they cannot attract major capital. No one wants to fund them. Because they have no capital, they can't build specialized production facilities. And because they have no facilities, they get no production experience. You are perpetually stuck at square one.
And that loop is self-reinforcing entirely because of mismatched timescales. Each node in that circle operates on a timeline that actively prevents the next node from ever waking up.
But hold on, if this trap is so obvious to anyone looking at a whiteboard, why doesn't a major venture capital firm just step in, realize what's happening, and fund the facility anyway to break the loop?
Because you run headfirst into the physical realities of time?
What do you mean?
Well, impatient capital, like your standard venture capital, typically operates on a quarterly timeline. They need to show returns, or at least massive user growth, in 90 days.
Right, the quarterly earnings report rules everything.
But pouring concrete and curing cement takes 30 days alone. Building a deep tech biomanufacturing facility, getting it permitted, calibrating the equipment, that takes years.
Decades sometimes to develop a specialized workforce.
Exactly. The physics of the physical world absolutely refuse to comply with a quarterly earnings report.
So the financial timeline literally cannot compose with the physical timeline.
Right.
The sprinter cannot hand off to the walker. So how do you fix it? The research says you have to turn the circle into a spiral.
Right. You synchronize the time frames. A government or a massive institutional buyer can step in and provide a long-term demand signal.
Like a guaranteed purchase contract?
Yes. That immediately compresses the capital decision because investors now feel safe on a much longer horizon.
Oh, that's clever.
And then pre-built, shared physical infrastructure can compress the facility timeline from years down to months. The spiral approach isn't magically speeding up how fast concrete dries. It is making the entire system temporally coherent.
Temporally coherent. When every node finally operates on a timescale that is compatible with the others. And this plays directly into a core economic principle mentioned in the text called Wright's Law, right?
Yes, Wright's Law is huge here. Traditionally, Wright's Law states that manufacturing costs decline predictably as your cumulative production increases.
The more units you make of something, the cheaper it gets to produce the next unit.
Exactly.
I think a lot of people assume that just means bulk discounts on materials. Like you buy more steel, you get a cheaper price. But mechanically, it's about micro optimizations, right?
Precisely.
Okay.
It is about the fact that on assembly run number 10, maybe an engineer realizes they can shave 3 seconds off a welding process.
Right.
And then on run 100, they discover a way to reduce material waste by 2%. Over 10,000 production runs, those tiny, mundane optimizations compound into a massive structural price advantage that a brand new competitor simply cannot match on day one.
But the Tempo Thesis completely reframes Wright's Law. It argues that this isn't just an economic principle at all. Wright's Law is actually a temporal claim wearing an economic costume.
It is a race against time. The first mover to achieve operational production will inevitably become the lowest cost producer.
Because they're learning faster.
Right, and that cost gap will only compound as time goes on.
Man, this is such a brutal truth for any builders or founders listening right now. Like, you might have the absolute best technology sitting on a lab bench. It literally doesn't matter.
It doesn't.
The winner is the organization that reaches operational deployment first and starts descending that learning curve. Time spent on that learning curve is the ultimate defensive moat.
Which frames the geopolitical stakes perfectly. Just look at China's current massive lead in biomanufacturing over the United States.
Right.
It is not merely a static disadvantage where they just happen to have slightly more factories online today. It is a compounding temporal disadvantage.
Because they are actively moving down the learning curve, optimizing their processes every single day.
Yeah. The learning curve actively steepens for whoever's on it, and it completely flattens out for whoever is stuck in the lab. Every single year that gap persists. The temporal distance between the two nations' capabilities just grows exponentially.
Wow. And in manufacturing, that compounding temporal math means lost money, lost market share, and eventually lost economic dominance.
But if you apply that exact same exponential math to a living organism, the stakes go from economic dominance to human survival.
Yeah, that is a terrifying shift, because that's the ultimate high-stakes test of temporal coherence. A biological threat, like a novel pathogen, it does not care about our institutional calendars.
Not at all.
It does not pause its spread for a notice and comment rulemaking period or, a quarterly board meeting. It replicates on its own timescale, and that timescale is aggressively exponential.
The difference between containing a biological threat in a single city and facing a global catastrophe is actually not a lack of scientific capability. We have the technology.
Right. We have rapid genetic sequencing. We have global wastewater surveillance infrastructure. We have the mRNA platforms to build countermeasures.
Exactly. The difference between success and catastrophic failure is entirely about temporal coordination.
It's all about time.
Yes. If we strip away all the complicated organizational charts and the capability matrices, biosecurity is purely an exercise in temporal engineering.
Temporal engineering.
Can a society detect a threat, interpret the genetic data, make a hard policy decision, and physically distribute a countermeasure, all within the doubling time of the pathogen?
So let me put this directly to you, the listener. Think about your own crisis management structures at work. It obviously doesn't have to be a global pandemic. It could be a PR nightmare, a massive server outage, or like a critical supply chain failure.
Very common crises, yeah.
Right. Are you just buying more expensive software tools to put out the fires, or are you actually engineering your team's response protocol to be mathematically faster than the problem's doubling time? Because according to the research, that is the ultimate design requirement.
That is the core metric of temporal engineering. You must compress the gap between the event and your response to be smaller than the gap between the event and the catastrophic consequence.
And if you can't do that,
If your response timeline is longer than the consequence timeline, all the capability in the world is just decoration.
just decoration. Wow. We've covered a lot of ground today. We've seen how time misalignments paralyze government policy. We've seen how compounding learning curves dictate who wins the global manufacturing race.
Yeah.
And we've seen how exponential math determines survival in the face of biological threats. So how do we actually apply this shift in thinking? Because the TCIP documents demand a really profound perspective shift. We have to stop looking at time as a dimension and start treating it as a domain,
Right. We culturally treat time like the weather.
like it just happens to us.
Exactly. It's this passive background condition. We complain about it, we feel rushed by it, but we don't actively try to structure it. The conceptual shift here is to start treating time like geography in warfare.
Like the high ground on a battlefield.
Yes. It is an active, physical space where structural advantage can be built, where it is fiercely contested, and where it is ultimately lost.
And if time is the high ground, that means it requires its own distinct strategy. It requires deliberate temporal design. We need to develop temporal literacy.
Which is really the ability to look at a failing project and realize that the binding constraint isn't a lack of budget or a lack of talent, but a structural misalignment of time.
So what are the actionable takeaways here? Like the frameworks we've discussed offer very concrete takeaways for different sectors, right?
They do. So for builders and engineers, the lesson is clear. Operational deployment is infinitely more valuable than lab perfection. You have to get out of the lab and onto the learning curve so you can start compounding your temporal advantage.
Yeah, that makes sense. And for policymakers and managers.
The takeaway there is to stop sending out memos demanding your teams just move faster. Instead, you have to do the hard work of building modular architectures. Build pre-authorization frameworks where the governance timescales natively match the speed of the domain you are trying to control.
Stop asking the walker to sprint.
Exactly. And finally, there is a massive recalibration required for capital allocators, like investors.
Oh, this is a big one.
We often view patient capital as some sort of philanthropic endeavor, like it's charity. But in fields like biomanufacturing, aerospace, or hard tech, patient capital is absolutely not charity. It is a strict, mechanical investment in temporal alignment.
Because impatient capital demanding immediate quarterly returns is temporally incompatible with the physics of hard problems.
Right. You simply cannot fund a 10-year physical infrastructure challenge with a 90-day financial instrument.
The sprinter and the walker again. It's wild how all of these distinct examples, from IT compliance to global pandemics, they all lead to the same overarching conclusion.
They really do. The timescale for developing a new AI model, the timescale for a virus replicating, the timescale for a bureaucracy holding a hearing, and the timescale for an investor wanting a return. None of those timescales are inherently wrong in isolation.
Because they're just doing exactly what they were built to do.
Exactly. But they are entirely wrong together.
They are wrong together because no one ever sat down and actually designed them to be temporally coherent. We just sort of throw them all in a room and hope they figure it out.
And we assume human systems will just naturally synchronize on their own, and the evidence shows they simply do not.
So bringing all these threads together, the core realization of the Tempo Thesis is really this. As a society and within our own businesses, we are incredibly skilled at designing capability. We know how to draw up org charts to design authority. We know how to design software architecture.
But we almost never design for time.
Right. We have to learn to think in time. We have to compose our pace of understanding, our pace of building, and our pace of governing into a single functional system.
It requires a completely new lens for leadership. You really have to become a temporal engineer of your own organization.
I love that. I want to challenge you, listening right now, to run a temporal audit on your own life or your own team this week.
That's a great idea.
Yeah, look for those temporal coupling failures. Where are you currently exhausting yourself trying to fix an execution problem or a personnel issue or begging for more budget when what you actually have is a time mismatch problem? Where is your world-class sprinter desperately trying to hand a baton to a system that is fundamentally designed to walk?
And just to leave you with something to really chew on, let's take this concept of time as a contested domain to its logical extreme.
Okay, lay it on us.
We spent this entire discussion analyzing how human institutions fail to align their temporal architectures. But if time is the ultimate high ground where advantage is won and lost, what happens when artificial intelligence systems begin designing their own temporal architectures?
Oh,
Right. If a network of AI models starts coordinating, iterating, and executing policy at a machine speed timescale that is entirely divorced from human physical limits, how do we possibly maintain temporal coupling with an intelligence that can iterate 1,000,000 times in the space of a human blink?
that is just a staggering thought. What happens when the systems we build start sprinting at light speed and humanity is the one stuck walking down the track?
Wow. Thank you so much for joining us on this deep dive into the Connected Ideas Project. Keep questioning the invisible frameworks around you, hunt down those temporal mismatches in your own work, and most importantly, start designing for time. Catch you on the next one.